Welcome to Summarize Science. Today, we are looking at a breakthrough in how AI maintains its focus on images. Have you ever noticed that AI seems to lose its way or make things up during a very long conversation? This paper introduces a concept called persistent visual memory to fix exactly that problem. The researchers found that standard models suffer from something they call visual signal dilution. Look at this diagram comparing different ways AI systems process pictures. Standard models let the image signal fade away as more text is written, leading to errors. Other methods try to force the image back into the conversation, but that often breaks the AI's train of thought. The proposed PVM system creates a parallel path that keeps the image in view without interrupting the logic. It acts like a dedicated third eye that stays fixed on the photo while the rest of the brain works on the writing. The research shows that as an AI generates a long response, the attention weight given to the image drops drastically. It is like trying to remember a photo while someone is shouting a long list of instructions at you. Eventually, the photo becomes a blur. They call this a high-magnitude saturation trap, where textual history simply overwhelms the vision. To stop this, the model needs a way to look back at the original image data on demand. PVM solves this by creating a dedicated looking path alongside the main reasoning path. It uses a silencing mask to make sure the AI only checks its visual memory when it is actually generating text. This keeps the visual signal strong and clear regardless of how long the conversation gets. Because it is a parallel module, it does not structurally change the main AI backbone, making it very efficient. When tested on tough benchmarks, this new memory module boosted accuracy across the board. In some complex tasks, the 8B parameter model saw nearly a 5% jump in overall performance. It proved especially effective at helping the AI maintain its focus during deep, multi-step scientific reasoning. Notably, these gains come with almost no extra computing cost during the inference process. This graph is particularly interesting because it shows the improvement gap growing over time. The longer the response needed, the better PVM performed compared to standard models. In the long category of responses, the relative performance gain surged by over 27%. This confirms that PVM acts as a critical stabilizer when the AI is deep in a reasoning chain. To prove it worked, the researchers used a blind painter test where the AI had to describe an image in extreme detail. Without PVM, standard models eventually started hallucinating or forgetting specific colors and textures. With the new memory module, the AI was able to stay grounded in the visual facts until the very end. This test forced the model to maintain a continuous, high-intensity dependency on the visual input. In summary, persistent visual memory acts like an anchor, keeping the AI's vision stable during long tasks. This means future AI assistants will likely be much better at analyzing complex diagrams or helping with long-form research. By decoupling vision from the growing text history, the AI can look twice before it answers. It is a clever architectural shift that leads to a massive leap in reliability for the next generation of AI. Thanks for watching Summarize Science.